In this example, we're going to find out the cost functions for the different production functions. So you are given with the production function of Cobb Douglas and perfect complements. Let us derive the associated cost function for them. So I hope you remember that yesterday we said that cost function will have the form W1, W2, and Y. That is, it is the function of input prices and output. That is the general form of the cost function. Note that this is not the cost function. Make this thing absolutely clear in your head. This is the objective function of the cost minimization exercise. So the general form of the cost function is this, which is the function of input prices and output. Right? Okay. Now, for the first part, example 1. So what do? You minimize W1x1 plus W2x2 subject to y equals to x1 x2, subject to y equals to x1 x2. So what do? You set up the Lagrange. W1 x1 plus W2 x2 plus lambda y minus x1 x2. That's what you do. So your objective function is this W1 x1 plus W2 x2, and you need to minimize this subject to this constraint, this production function. So del L by del x1 is what? W1 minus lambda x2 equals to 0. Del L by del x2 is W2 minus lambda x1 equals to 0. And del L by del lambda is equal to what? Y minus x1 x2 equals to 0. Right? So this is what my equation 1, equation 2, and equation 3. So you divide first by second. What will you be getting? W1 by W2 is equal to x2 by x1. I'll be getting this guy. So what is my x2? X2 is W1 by W2 x1. W1 by W2 x1. You can substitute this x2 back into substitute x2 equals to W1 by W2 x1 in 3. So what will you be getting? Y minus x1, and in place of x2 I'll be writing W1 by W2 x1 equals to 0. I'll be getting this guy, right? So that would mean what? Y is equal to x1 square W1 plus, and sorry, W1 by W2. So x1 square is what? W2 by W1 y. X1 is what? Root of W2 by W1 y. This is what it is. Now, if you look at it, this is the conditional demand function for x1. This is this much input of or this much amount of input 1 is going to be demanded by the firm, right, at input prices W1, W2 in order to produce the output y. So if you look at it carefully, this is the conditional demand for input 1, which is the function of W1, W2, that is your input prices, and output, that is your input prices and output. So if you link it to the earlier class, this is what you did, this is what you said yesterday. This is what you said yesterday, that this has to be the function of input prices and output. This has to be the function of input prices and output. Now look at it this beta. You have written x2 is what? W1 by W2 x1. W1 by W2. In place of x1, you guys can write root of W2 upon root of W1 into root of y. So this will come out to be what? This will come out to be W1 by W2y. This will come out to be W1 by W2y. So this is also the conditional input demand. Conditional input demand function, right? So it is conditioned upon that you have to produce this much of output. This is the conditional input demand function. Okay. Now, the moment you have your conditional input demand function, what you can do is that you can substitute in the objective function of the cost minimization in order to get the cost function. In order to get the cost function. So what is the objective function of the cost minimization? W1x1 plus W2x2. This is what you have minimized. This was the objective function, beta. You need to minimize this guy with respect to this. I mean, subject to this, right? So I'll be substituting this. So W1 in place of x1c, what is it that I can write? Root of W2 by W1y. Plus W2. In place of x2c, what can I write? Root of W1 by W2y. So beta g, this will come out to be what? Root of W1 W2y plus root of W1 W2y. So this becomes what? 2 root of W1 W2y. So this is what my cost function is. This is what my cost function is. You with me, beta? So as you guys could see, this cost function is the function of input prices and output. This cost function is the function of input prices and output. This is what you can see, right? Okay. Now what about this function? F of x1, x2, which is min of x1, x2. So example 2. This was your example 1. Let us look at example 2. So you are given with f of x1, x2 is equal to min of x1, x2. So this is what? This is your perfect complement kind of technology, right? Perfect complement kind of technology. So you will be producing at the kink. Where is the kink? Kink is at x1 equals to x2. So at the optimum, beta y is equal to x1 is equal to x2. You will be producing at the kink now. So I hope this guy is clear. I think in one of the recording. So as I remember, I think I did this. Yes, for this production function. So in the earlier recordings of the production theory, you guys could have a look at this. So you'll be producing at the kink, right? So when you'll be producing at the kink, acha, one more thing I have also told there. I'm so sorry. Yeah, you'll be producing at this point now. So your production is going to be like this: Q is equal to AK equals to BL. That's what you're using here as well. So you'll be producing at this particular point. Y is equal to x1 equals to x2, right? So when you write x1 equals to y, what is the cost of using x1? W1. So this is the cost of using x1. That is W1 x1, which is written as W1y. हाँ बेटा, cost of using x2 is what? W2 x2, right? And when you write y is equal to x2, so cost of using x2 is W2 x2, and since x2 is equal to y, so that means W2y. Now you tell me one thing. This is for that kind of production function when you do not have a choice of using a cheaper input. So whatever be the price, you will have to use both of these inputs in this ratio only. There is no other way. So do you have a choice? You don't have a choice. So the total cost is what? Total cost is cost of using x1, which is W1y, plus cost of using x2, which is W2y. This could be written as W1 plus W2y. And this is the function of W1, W2y. This is the cost function which you have, the function of input prices and output. This is the function of input prices and output, right? This is the function of input prices and output. That is, do you have a choice of using a cheaper input? No, na. You have to use both the inputs. There's no other way. You will definitely have to use both the inputs. So whatever be the prices, you will have to use both the inputs in this ratio only. So this is an example for getting the cost function. So yesterday you learned how do you write the cost function. Uh, that is, first of all, what you learned yesterday was that the optimal is going to be at the tangency. That is where isocost and isocont line are tangent to each other. Uh, so here also, if you just have a look at this, this is what you have done. So what you have done is that if you want to have this as the production function, this was the production function which was given to you, and you want to find out the point of an optima. So you found out you have, and this is what an equation of the isocost line is, which is what W1 x1 plus W2 x2. And from here, what you have done is that you have been able to find out the optimal amount of inputs. That is what you have been able to find out, the optimal amount of inputs as the function of input prices and output. So the only thing is that you are given with the output, you want to minimize this, right? Here also, what you did for the perfect complement case, you had this function, you were given with this function y bar, and then you sort of found out these points. You minimize this. Of course, beta, this line could also have, note that this isocost line could have also produced y bar. But the point is, you need to find out the minimum one. That's what you did. Huh? That's what you did. And here also you've been able to find out that x1 star and x2 star. That x1 star and x2 star. So this is what the few examples, that when you are given with the production function, how do you find out the associated cost function for the same? Right, beta? Chalo. Thank you very much.